All right, so welcome back. This is the last week of this class. Obviously, these classes are pretty short. We've been experimenting with shorter classes, so it definitely feels like it's, one week it's starting and then the next week it's ending, which happens, but hopefully you're finding some value in this class. So we'll talk a little bit about potentially doing a show and tell in a couple weeks. So if you are interested in sort of showing your work, I find it's a good motivator to keep moving on things even after class is over. So um, we will talk about that in just a minute. Let's kick off just with sort of where we are with class. Actually, I think the first thing we're going to talk about is the show and tell. So let me just share my screen really quickly. All right, so obviously, it's the last week of class here. We're going to go mostly over class labels or how to do what would be described as a conditional GAN. We sort of said we wouldn't be doing this in class, but then I realized it takes a little bit of effort to get everything up and running. So I built a notebook, and Leah is going to walk through much of what we see here. So hopefully that'll be a good sort of intro to making images and videos and give you some ideas on how to generate some stuff for your show and tell class. So there is a show and tell poll here. So please take a look at it and sign up for like what times you think would be a good time to do that. I think, knowing what we know about some of our friends in Europe, this is maybe not the best time to do a show and tell. So hopefully we can find a time maybe a little bit earlier in the day on the weekends or another time to do a show and tell where everyone's available. So take a look at that poll. It's linked to here, and fill out what times you're available or free to do to be a part of that. Again, the show and tell is optional, but I do find that it's a really good motivator, and it's kind of cool just to see what everybody made after a couple weeks. We also have an in-a-class survey, so Leah and I take all of your feedback very seriously. So please take a look at that and give us feedback on what worked and what didn't in this class. We try to do that and iterate on that and use that as sort of the starting point for the next round of classes. We've changed classes quite a lot in the past year, and I expect us to keep doing more of that. So please give us feedback. I think Naoko asked if we're going to be teaching any other classes for the end of the year. We probably won't, just because as the holidays hit, it gets really weird scheduling wise. So I think this is pretty much it for the end of the year. But what that means is that gives Leah and I more time to sort of figure out what we're going to do next year. So if you do have ideas for classes you want to see us produce or would maybe join, let us know in that survey. We'll happily take advice or feedback on those sort of things, because it's just really helpful to sort of hear from people what they're interested in. Last note is to sign up for one-on-ones. I believe there's a slide at the very end of this slide deck, as well as we'll post them in the Slack channel on signing up for one-on-ones with us. So again, especially if you're going to show up in the show and tell, or like want to talk about through projects you're going to show there, like it's a great moment to sort of like get feedback or get help through certain things then. So I would say, like, if you're interested in doing the show and tell, maybe sign up in the next week or two to do one-on-ones with us so we can help give you feedback and help you work through those projects. Cool. Leah, anything you want to add here?
Oh yeah, this is just a link to our last show and tell, which was in like April or March of this year for the last StyleGAN class. In general, like, yeah, it's totally optional. Like, you can just show up and just listen to your classmates, which is also a really, really cool experience. Hearing everybody's experience and their thoughts on the entire process. But if you do want to present, you can present with slides, or you also have the option to pre-record a video. Like if you have an internet connection that is a little wonky, or if you just want to, I don't know, pre-record something so you have it prepared in case presenting live is not for you. And yeah, there's a link to the poll to set a time. The entire show and tell might take about like less than 2 hours in total. So when you're filling out the poll, pick times that work for like start times for a 2 hour slot. Looks like Derek may have dropped off. I'll go ahead and share my screen. Yeah, so that's pretty much it regarding the show and tell. Do you guys have any questions about it? Logistics or anything? I think like after people sign up, we can figure out like some kind of order. Yeah.
Hey, yeah, speaking of wonky internet, yeah, and I think, I don't know if Leah mentioned this, but I think usually we do about 10 minutes per person, and that'll sort of depend on how many people we have sign up. And usually it's about a 2-hour session. And again, you can sort of show up when you want to or show up and hang out. It's sort of up to you, but it's kind of a fun moment. And we will probably like live stream it over YouTube. So it's like fun to share it with friends and have them come and see like what you made or whatever. Yeah. Cool. Sorry about that. So this week we will be, as I mentioned, so I have some updates just on sort of generally things that I've found with the repo, as well as I've been writing lots of code this week, and to update some things for us to make things a little bit easier, as well as some other stuff. So I'll go over that, and then we'll talk a little bit about conditional style GANs and having class labels. And then, as I mentioned, Leah will cover most of the first part of Inference, and we have a notebook on how to generate images and videos and other things. And then if we have time, we might look at some more advanced stuff, like maybe looking at an audio reactive example. I know Naoko was asking about this. I do have a notebook for this, so regardless, like even if we don't get to cover it, you can still go through that notebook and play with things if you're interested. But we'll just sort of see where we end up with time, because some of this can take a while, and we'll see how it goes. Cool. Okay, so some updates. As I mentioned, like this is a brand new repo, and I've only sort of had 2 weeks to play with it myself. So I'm sort of learning as y'all are learning, and we're sort of learning things together. So I appreciate people dropping questions in Slack about various things they're trying to figure out, that sort of thing. So I have some updates. So the first thing is I pushed a bunch of new changes to the repo. So you probably want to make sure you update to the latest version, especially if you're interested in generating images and videos from your own repo, because most of that code didn't exist until a couple days ago. So if you're in Colab, this is basically what you want to do is you want to copy and paste all of this into a brand new cell in Colab and run that cell. One thing to note is that this line here, oops, sorry, this third line is all one line. So make sure it's all one line and not broken up into separate lines. It probably will break otherwise. So you just want to CD into that. Will and I were trying to figure out what the deal was going on with like various Git issues. I think this should solve everyone's Git issues. If you run into problems with it, just let me know and we can try to troubleshoot it. But basically this will update these particular files, which should give you like the latest version of everything. So this is how to do it in Colab. If you're on Paperspace, this is how to do it. Just run each one of these lines as a separate command inside of the Paperspace terminal. So you'll just do CD into that folder. Then you'll run that git config. So run each of those as a single command in there. So that should give you the latest version as of like 3 hours ago. So we should have a bunch of new code and things to play with in there. And some of those are like things for image generation. Some of them are things for stuff we'll be talking about in a minute, like right now. So first thing I want to mention, and I think I mentioned this in Slack, but just for folks who maybe didn't catch that, there was an example that I sort of showed last week of like a potential mode collapse where basically all of my flowers started to take on the same structures. And I have sort of found since then that if I keep training it more and more, the mode collapse like slowly goes away, or just gets like, it gets smarter and it builds in additional structures. So I would recommend that if you're sort of seeing similar issues where you're seeing sort of maybe bigger global structures that seem to be repeating a lot, try just training it longer. And if you're in Colab, that just means resume it and keep training it. If you're on Paperspace, just train it for a longer period of time. So I have found that to help quite a lot. And that makes sense because one of the things I found sort of funny is that they're running, the NVIDIA folks who like built the repo were running their stuff for 25,000 K images, which like, I think that ends up being like almost a month on Colab. And I was like, why are they doing that? Because it's clearly like it generates good results like pretty quickly. And it might have something to do with this. I think that's probably still overkill. But I think it probably has something to do with just like generating better images as you train it longer and longer and longer. Now, there are still issues where like the whole thing collapses. And that's just sort of a general issue with GANs. And we can sort of play with some learning rates to maybe fix that. But we'll just sort of see. I haven't added any code to change learning rates, but that might be something that I look at in the next week or two. So another thing I mentioned on Slack is that this complex config, and I know Will found this, the complex config tends to like collapse, like it just turns to like mush or like a singular color. And like, my intuition would be like, oh shit, turn it off and like restart it. But actually what I have tend to found, I think Will, you found this too with one of yours, like it goes to mush and then it comes back and it trains well. And I have no idea what's going on there, but I just know that that's sort of what happens. So I don't have any visual examples in here, and I should probably grab some, and maybe I'll do that tonight. But I had an example of where like it started training okay-ish, and then it like dissolved to black, and then it comes back from black into like a good result. No idea what's going on there. It might have something to do with the fact that like we're changing configurations, we're moving from like a certain network style into a new network style, and it's sort of like undoing that to redo it. But for whatever reason, that's what happens. So if you're using the complex config and you happen to see it like turn to black or turn to a singular color, might just be a thing that happens. And I would say let it train for a little bit longer and see what happens. Here's another one that I know Will found, and Will, I just add this code so maybe you and I can look through it and see what happens, which is this case of if you're training in Collab a lot, you will see an error message that says drive quota exceeded. Essentially what's happening here is every time in Colab you're running a cell to like start training, what it does is it transfers all the data from your Drive account into Colab, and that causes like it's sort of like Google charges you a fee for that. It's not really a fee, but like it keeps track of how much data you're transferring around. And when you hit a certain level, it just sort of says like, oops, you're over your quota. You're done. You're done for today. And you need to like wait until tomorrow to start doing that again. So in the case of if you have like a small data set, like say 1,500 images, 2,000 images, and you're running it say every 18 hours, that's probably fine. In the case of Will and I, like we had some data sets that were really, really big, like say like over 5,000 images, and those data set files end up being really large. And if you make like a single mistake or like try to restart a training, sometimes transferring that much data, which can be like in like the tens of gigabytes, it throws a drive quota error. So just be aware of that. Like this is basically another issue of like where if you've been in any of my other classes, we talk a lot about using GDown. GDown can also have similar issues. So if you're downloading lots of data and moving it around, it can just be a problem. So that's why sometimes I do the hacky thing of uploading stuff directly to Colab, which will generally be slower, but it sort of avoids that whole like Google Drive looping issue. So there's lots of ways to get around that. But the key thing is just to like, if you're going to use Colab a lot, to just be careful and think about how much data you're moving from Drive to Colab frequently. I did add some code for a new solution, which is to use this thing called raw data. I'm not really sure why it's called raw data. I just know that it sort of like works and it produces much smaller data sets. I think it has something to do with the way that TensorFlow encodes certain data pieces. So basically the way that works is there's now there's two new commands. So when you're making a data set, instead of using create from images and then passing in the path and whatever, there's a new command called create from images _ raw. And this will produce a much, much smaller data set. And we'll look at that in just a second. But then it will be able to use that data set as your new data set. Basically, the way StyleGAN worked before StyleGAN2, I guess, is it used to need levels, used to need different levels of detail, powers of 2, and they would create all these files. So when you actually look at your dataset files, you'll see R2, R3, R4, R5. Those are like certain power levels. And basically we don't need those anymore. So in the newest version, like we don't necessarily need all those files. So we can sort of remove that stuff. So if you use this command, that'll generate those files. And then what you want to do is if you're using a raw data set, you'll make sure that when you're running your training command, that you use this additional argument at the very end, which is -- use - raw equals true. I've set up the repo to work like assuming that everyone in this class like didn't make raw data sets. So the default is to use the non-raw version. And if you want to change that, you want to use this argument. So here's an example of what that actually looks like. You can see at the top here is a data set that I made. This is 1,500 images, 1,500 5 by 512 by 512 images. And you'll see at this R09, which is the highest resolution, that is 2 to the 9th power, that is 512. You get a file that is 1 gigabyte. And if you were to do a 1024, it would be like 4 to 10 gigabytes. And that's with 1,500 images. If you have more images, it's going to be even larger. So you get a pretty big data set when you use like the default data set conversion method. When you use the convert from raw, you'll see you get a file that is 65 megabytes, and that is the largest file. Don't necessarily worry about the R. It translates a little bit differently, but essentially, like you can see here, like this is only one 65 megabyte file, whereas this is probably almost 2 gigabytes of total files. So you save a lot of space. So just be aware of that. And like, if you are finding that you hit drive quota issues or other things, this is a good way to get around that. I would also say, like, in general, there's been some debate that maybe raw files produce worse models, but I haven't really seen that. So, maybe try it and see if you find that it's helpful. It certainly means less data being moved around, which is always good, and maybe means a little bit of a speed up overall. So try that, see what you think. And if you have any questions, you can reach out to me and I can sort of help you walk through things. Another thing, so let's see. So Matt, I think, asked about this question. Yeah, as mentioned by Matt on the slide. There is sort of this thing going on that the repo does, which is that it changes the augmentation strength over time. So basically, when you start training from like very beginning, the augmentation is a probability of 0. And over time, it gets higher and higher and higher. What that means is that if you're restarting your training fairly frequently, you might not see the highest strength augmentation either ever, or just like it might be slow to get there. So particularly in using Colab, you might run into this issue. The truth is, I haven't really seen this be an actual problem. Even if you're running on Colab Pro, which gives you like 20 hours, I've still seen the p-value reach pretty high. So I don't know that this is an issue. And I haven't really seen it be a huge effect on quality. But in the case of Matt, who I know is running his overnight, where maybe his total runtime is 8 hours, you might actually see some issues where it never really reaches full convergence or full like quality, because it's never hitting that really high level augmentation, which I think is going to help a lot with the details. So might want to think about that. There's a link to a GitHub comment on like maybe how they're going to fix it. I'm probably going to keep looking at this and maybe see what other folks are doing. So this is such a brand new repo, like not a lot of people have gotten to like doing these sort of fixes yet. But if I find that someone has sort of solved this, I might sort of merge that into our repo. I would say overall, I wouldn't worry about it too much, but just, especially for someone like Matt, who I think is doing probably the shortest training times of anyone here, it might just be a good idea to keep an eye on it. Any questions about those updates? Cool. I haven't yet included the raw stuff in that training notebook that I've shared with everyone on Colab. I'll probably try to get to that tonight or tomorrow. But if you are interested in trying this ahead of time, just let me know and I can sort of send you the code that you'll need to update. It's pretty minor, but it does have some benefit. Cool. So let's talk a little bit about training with class labels. We talked about this a little bit, and especially we talked about this a little bit in the dataset class too, of like, so we've got sort of two concepts here, right? Which is like, let's say I want to train like some animal faces. The way that StyleGAN sort of out of the box would do it is if you would find a bunch of animal faces of different animals, you could mix them all together and like it would have like a zoo generating model. This is good. It's going to produce a lot of faces that might be weird between like cats and dogs. And maybe you want that, maybe you don't, it's sort of up to you. But the idea is that sometimes you might want to actually separate those out into individual models. And the idea here is like, you could train these all as individual models, right? You could find 1,000 wild animals, you could find 1,000 dogs, could find 1,000 cats. You could train each of those individually. Then you've got 3 model files you have to worry about. You've got 3 trainings that take 3 days instead of 1 day together. One thing that's good about something like this, where you sort of like are using the same data but separating them out into what we would call classes. You'll hear people either refer to this as class or with classes or with like a conditional. Conditional meaning that it's either a condition of A, B, or C, right? So it's sort of like, which of these conditions am I applying to this? One of the reasons you might want to do this is like these faces all have some similar structures, right? They still all have eyes, they still all have noses, they still all have ears. So the model, even when it's trying to like define all these shapes, can use data from each of these data sets or each of these classes and actually still learn together. And all you're doing is at some point you're saying, hey, make sure that this is assigned a a class of wild animals or a class of dogs or a class of cats. And this is a pretty common thing you'll see people do with GANs, is like the idea of having more control over your GAN to say, I want to generate a dog, or I want to generate a cat, or I want to generate a wild animal. So out of the box, you can technically do this in StyleGAN like out of the box. The problem is like the dataset creation tools aren't really there. So this week I added the dataset creation tools to make this a little bit easier. The way you previously had to do this was just like reading through a bunch of Python data to get it, and it just like didn't make sense to me. I don't think it makes sense for most of us as artists to like actually work that way. So what I have done is set it up so it can read from different folders. So if you make a master folder, let's say you call it animal, and then you make 3 folders inside of there called wild animals, cats, and dogs, and then you fill up all of those images into that data set, we can then create what we call a labeled data set from that. So this is an example of one that I tried this week and didn't work well. And I have some ideas about why that is that I'll talk about in a minute, but essentially like the idea here is that you could create classes of just folders, and you could put all the images in there. Now make sure that the images are all the same size, right? So it still needs to act like a normal data set. They all need the same size. They should all be square for now. And I think realistically, it's probably a good idea if they're all an even amount. So I think one of the issues that happen with this data set is I have one folder that has like 1,000 images and another folder that has like 100 images in it. And I think that unevenness can cause issues. So I would try to make them pretty even. They don't have to be exactly even, but like if one has 400, one has 500, one has 550, that's fine. But if you've got 101 and 1,000 another, that's probably going to cause issues. So I would just keep an eye on that. But basically, like just put them in folders. Once they're in folders, you're going to run a command called create from images. So right now there's a thing called create from images, and instead you want to change it to create from image folders or create from image folders raw. Both of these will work. This one produces those really big data sets. This one produces smaller data sets. When that runs, you will see something spit out to the console that says something like this, which is this folder is assigned a label of 0. This folder is assigned a label of 1. This folder is assigned a label of 2. You kind of want to screenshot that because this is now your key. So when you go back to generate images, if you want to generate a silver mineral, you want to make sure you label it with 6. So unfortunately, the way that these models work is it's all mathematic, right? So there's no like actual text label. Every label is given a number, and those numbers are what sort of becomes the output here. So make sure that you sort of are aware of that. Because it's really important for future cases. So once you've made that data set, it'll produce a data set. It actually looks very, very similar to the other data set, except there's another file that's called, what is it? It's actually here. It's this, it's the rxx.labels. So that's how you know you have a labeled data set. When you train, your actual grid of images will also look a little bit different. So this is a 512 data set, so the images aren't as large. But you can actually sort of tell this is also labeled because if you look at the rows, you'll see that this row here is all wild animals. This row here is all dogs. This is all cats. And then it goes wild animals, dogs, cats, wild animals, dogs. So across the row is the label. So this sort of helps you make sure that it's training well, that it worked, that sort of thing. So just be aware of that. This is, I believe, are these reals or are these not? I don't actually know. I think these are fakes because this cat is looking a little gnarly. So yeah, so just be aware that as it spits out fakes, you will see these things. I posted an example to Twitter that was a little bit earlier version of this, and this dog also looked really screwed up. So you can tell it's still training a little bit, but it looks pretty good. I mean, this is like, I think 2 days of training. It looks pretty amazing for this. So once it's training, you let train just like it would anything else. There's nothing else you need to set up in the training method. When you go to generate your images, there's one additional line you need to add. This is included in the notebook that Leah's going to go over. But if you have a class data set, you want to make sure you include your class back in. And this class number correlates to whatever those labels were. So make sure you have that label key, because if you don't, it's going to be like, I don't remember what I wanted to produce here. If you don't include this label, this class label key, it always defaults to label of 0, which means in this case, we'll always generate wild animals. So if you don't include this, it will be like, I don't know what you want from me. One thing to note here is I'm definitely seeing almost like some overfitting, or like, sorry, not overfitting, load collapse. All these cats look pretty much the same. I don't know why that is, because my cats here look pretty different. So maybe I need to dig into that and figure out what's going on there. So some warnings about, or just notes about this process. When you train, you can't, you have to train from scratch. So you're going to set resume to none. The reason for that is the network itself includes the labels. So unless you have a model that has the exact same number of labels as what you've trained from, it can be an issue. So basically, like if you have, if you've done this a couple of times now and you have a model that is also 3 different classes, you can resume or transfer learn from that. Most of us probably don't have a lot of data sets running around with like the exact same number of classes, so you can't really do that. One thing to note is like you can continue your training off of your own models. So you train it for a day on Colab and you restart it, you can resume off your previous data set. So this is only when you start from the very beginning. Another note is that it's not possible to interpolate between these classes. So it's not possible to create a video of a cat changing from a cat to a dog to a leopard. If you want to do that, you want to go all the way back and you actually want to train this data set. So that means no class labels. So the question is like, why would I do this? The answer is you want more realistic looking classes, meaning you want more realistic looking wild animals and more realistic looking dogs. So if you were to merge all these, you might get a bunch of weird stuff, right? And the more diversity you have in your data set, the more problematic it's going to become. So classes are a way to maybe fight some of that. I personally find that it's less fun because you want some of that weird stuff as artists. But if you're more interested in just like getting more realistic images, then class labels are the way to go. Yeah, so it is not possible to interpolate between classes. So just be aware of that. But you do get pretty nice looking realistic cats or like, you know, within your classes, pretty realistic looking images within that data set. So this is a cool thing. I haven't seen a lot of people play with this. I think I've really only seen one model besides this one that I'm training now that is done this way. And there's a wiki art model from Peter Bailey's that is trained on wiki art. So you get different portraits of different people at different classes and other things. That's pretty much the only conditional model I've seen elsewhere. So I haven't seen a lot of people building with this, especially off StyleGAN. I think in part because it wasn't really clear that you could do this directly through StyleGAN until later. I'll also say there's probably a threshold for how many classes you can run. So I've seen people try to train this on what's called ImageNet, which is another data set that has, I believe, 1,000 classes, and those just turn to soup. It probably has too many classes and you probably need a different architecture to manage sort of that many classes. So this one has 16. This one didn't work out well for probably a couple reasons. It was probably too diverse and the folders themselves were a little bit unbalanced, and then it maybe has too many labels as well. So you probably want to play with it and sort of see what you can get away with if you're really interested in this. But yeah, it's a pretty cool tool and it could be really interesting depending on the data set you're trying to make. Any questions about that? All right. So I'm going to hand it off to Leah to have her start covering inference, and we'll probably take a break in the middle of that.
Yep, sounds good. Okay, so let's say like you have trained your model and now you want to like actually get images and videos out of it. What that process is called inference. So this, you can imagine this block here is your trained model, and you want to get new images and generate new images and videos out of it. So what is actually happening, if you guys remember the latent space, like that 512 dimensional space with these points in it, is every single point in that latent space that's learned by your model during the whole training process corresponds to an image. So here, this point might correspond to this image. And there are a lot of different words for inference. It's also known as evaluation. It's also known as testing. But in general, it's just taking a model that's trained and then getting new images out of it, like getting new fakes. So we do have this notebook, which has everything regarding generating images, doing these other things that I'll talk about in a second, truncation, interpolations, which are those like the StyleGAN, stereotypical StyleGAN like morphing videos, near neighbors, style mixing, flush digressions, and projection. So if you open up this notebook from here, you'll come to Colab. There's some setup cells. So the cell here, we'll just go ahead and download the entire StyleGAN2-ADA repo into here. One thing to make sure is that you don't run the cell multiple times, because you'll end up having like multiple nested repos, which you only need one. And then also you will need to download your trained model. So once your model is done training, you can use GDown to download it. Yeah, and then once you have it downloaded, you can specify the name you want for it. So here it's just defaulted to network.pickle. And I believe this is a model that Derek trained. Yeah, so this section here, generate images, this is the section that will actually get you, given your network, your pre-trained network file, and you can pick a couple of seeds. So each seed actually corresponds to one of these dots. So here I'm saying like, oh, I want seeds 0 through 10. Each seed is just specified by an integer, some whole number. So this command will actually output 10 different or 11 different images. So it's just this command, Python generate.py, generate images, and then you plug in the name of your network, which is here. Put in how many seeds you want. So if you wanted, like, let's say you wanted 50 images, you can just do seeds 0 through 50. And this is the name of the output directory that all of these images will be saved in. So these images will be saved into here. So if I go ahead and run this, I've already run this before, but I probably don't want 50 for the sake of this demo. But we can go ahead and run this and it'll output them into here. I have kind of like a cooking show already prepared all of these. So these are from the model that Derek trained. Derek, what was this trained on? What was the data set?
This was trained on video from a Stan Brakhage film.
Okay, so these are the different seeds. So this is seed 0, seed 2, seed 1, seed 5. So each of these like seed numbers is just a pointer to that specific image. So if I wanted to regenerate, if I said I really, really like seed 1, if you put seed 1 into here, you can get back that specific image. And so this command here will go ahead and if you don't want to download the entire folder, you can view them inline here. And if you do train a conditional model, like Derek just mentioned, it's the exact same command, except for here, input your class. So like if you wanted cats from the previous example, you'd put class equals 2. Yeah, and that is it for just generating like fakes from your trained model. Do you guys have any questions so far?
How high can the seed numbers go?
They can go, they're unbounded pretty much. You can start at 0 and go to like, I don't know, 1 million. And there's no rhyme or reason to their order pretty much. You can just pick any number.
Can you make a list or does it have to be a range?
Yeah, you can, yeah, exactly. You can put in a list. So here, if I knew that I liked, I don't know, seeds 1 and 5 and 1,000, doing that will generate just those images for those seeds. And those should be in here.
Oh, you know what? You lost your equal sign. Yep.
There we go. Yeah, so generating image for seed 1. Go ahead.
For those of you who are like familiar with maybe generative art or processing, a seed is literally just like a random seed in processing. So essentially all it does is it creates a placeholder and then you generate, what it actually does is it creates a placeholder random seed value. And then when you generate 512 values to generate your actual like vector, it just remembers that, right? So it's like 1 is essentially a placeholder for some 512 dimensional vector, which you could figure out if you wanted to, but like you kind of, it's easier to remember 1 or like 10 rather than is like, you probably can't remember 512 like vectors of like between -1 and 1, like unless you're like some sort of weird math genius.
Mhm. Any questions about inference so far? No? Okay. Another thing you can do is truncation. Truncation is a parameter within StyleGAN2 that determines how realistic an image is, and it controls like the diversity of your generated fakes. So here's an example of a truncation video. So it starts off pretty realistic, and then as the truncation gets reduced and deviates further and further from zero, it'll get more and more like crazy and wild. So if you want very realistic fakes, you want a low truncation value, or like close to 0 or 1. And if you want a very like weird sort of out there image, you can set your truncation value to, I don't know, like 5 or -5. Truncation is a value that can take on decimal values, and it's sort of like an infinite amount of space. But the range that most people tend to operate on is around like -1 to +1 or -2 to +2. So what is actually happening during truncation is like going back to the latent space of StyleGAN that gets trained and learned during the training process. Is truncation actually like truncates that space. And so it takes your vectors, and with higher values of truncation, it'll actually truncate those vectors. And then as a result, like, I don't know, I'm not sure exactly how it works, but I think the way I think about it is the extremes of the vectors get kind of like cut off. And then the more you truncate, the more average your image is, and the more like realistic and looking the image is. A side effect, or a trade-off of making your images more realistic is that they will be less diverse, meaning that a lot of them might end up looking kind of similar. And so if you want more diverse images produced, you want a lower truncation value. You want to truncate less. And so going to the notebook for truncation, here is the same command, or same script, generate.py, but here we pass in this argument truncation traversal. Again, you can put in the path to your network file. Here, this is on only one seed. So here, in this video, this is only one seed, and then all we're doing is from that one point, we're shifting that truncation value and deviating that one. So here you can pick a seed that you like, if you like seed 1. And then what is going on in this script is you can start, or what this start value is like saying is start at truncation value -2, go scrub or like increment all the way up to truncation value 2 with this step value. So it'll go from -2 to -1.75 all the way up to 2. And you can specify an FPS for like how smooth you want your video to be. And this out directory will be where the images are saved in this TT truncation traversal folder. So if you run this, it will put them all in here, saved as frames. And Derek wrote this code to actually splice together all of those frames into a video, which is really nice. And if you want this video, you can just go ahead and download it. Let me show it here. It moves pretty fast.
I think you're only sharing your tab right now, so we can't see the video.
Right. Okay, let me share my desktop. Okay. Thanks, Derek. So here, this is the truncation traversal video. It starts off like realistic and then gets kind of, so this looks like an image that was generated at like a normal truncation value. And then as we move the truncation value all the way up to 2, it gets more and more. I don't know, it decays more and more. Yeah, it's generally easier to see with like realistic photograph images, but with abstract things, yeah, you'll see it come out as well.
Yeah, just one thing to note is this starts at -2 to 2. So it's actually in the middle is like the 0 point, which is also maybe confusing. Like I would say maybe if you're starting this for the first time, say your start value to be 0 and then your stop value to be 2. And then you might want to, like, for this like cooking demo, it's totally fine to set your increment pretty high, but you might want to set that increment to be much lower and you'll get a much slower animation. You know, this is generating, I think, like 17 frames total. So if you were to set that to like 0.01, it would generate like a lot more. Basically, that increment value is per frame, how many of the truncation value are you moving out, right? So at this 0.25, it's going to be like you hit 1 after 4 steps. So if you make that smaller, it'll be much less.
Yeah, that's a really good point. Yeah, it's literally like generating each of these frames. And so if you want a smoother video, you would want more frames.
One thing to note, the generate images command above also takes in a truncation value. I believe it defaults to 0.5, which is like a general sort of safe value. But I think if you want to change it, I think it's --trunc, and then equals a value. Excuse me. So if you want to set that to be 1.0 or something, you could do that as well. So you can definitely keep an eye on that or play with that value and get different types of images out. Now remember, all the truncation value is doing is sort of changing the bounds. So seed 1 is still the same vector value, but depending on what your truncation value is, you might get a different image. So it's important to remember that, like, realistically, the same image is the seed value and a truncation value sort of combined. That will produce the exact same image. That gets a little confusing because you might want to be like, oh, I want seed 1, but then I'm going to change the truncation value and I get a different image out. What's going on there? So just be aware of that.
Yeah. So if you find an image you like, you need to know, in order to generate that same exact image again, you need like the seed and also the truncation value. So often if I have my seeds here, I'll like rename them to like dash truncation of 0.5 or something. So I just remember how to get it back.
Yeah, I could probably actually add that to the way those names are generated. So maybe I'll look at doing that in the near future as well. One other thing to note is no one should set their truncation value to be 0, 0 or like 0.0. The reason for that is that if you set it to be 0, you will only ever get one image because that the truncation space is so narrow that there's only one image available in that space. So when you set like FFHQ or other things into like 0, 0, people will generally call that the most average image in your data set. And it only ever produces the exact same image. So if your truncation value is 0.0 and you try to generate 50 seeds, they will be the exact same image, which can be a little confusing or like hard to wrap your brain around. But basically, like, you don't ever want to set it to 0, 0. It just doesn't make sense unless you're trying to find that actual like average image. Yeah, just be aware of that. Other notes about trunk. So negative and it can go positive. Most people tend to just use 0 to 1 or 0 to 2. It does have an infinite value. You can do 1000 and it will be very, very weird. It'll basically just be like weird RGB noise. Like after a certain space, it just like becomes blobby noise, which maybe is cool, maybe is not, but like you don't really need to like train your model to generate that sort of noise. So yeah, just be aware that like most people stick within like bounds of 2. Maybe they go up to 5, but it's still like pretty weird.
Yeah, and this is the most average face in FFHQ that we were talking about. So if you set your truncation value to 0, no matter what seed you put in for FFHQ, you'll get this woman out. And with that, I think we're due for a break.
Cool. Yeah, let's do 5 minutes. So yeah, so why don't we come back at 5 till? See everybody in 5 minutes. I'll have Leah.
Okay, I just saw the animal faces you posted. They're really really out there.
Yeah, so I posted some animal faces in the Slack channel of basically what happens when you run that data set that I was showing in the beginning without the class labels, and you end up with cats with like lion manes. It's very cute and funny.
Okay, let me share my screen. Okay, so the next thing you can do, I'm going to talk about interpolation, which are those smooth videos that you usually see with StyleGAN. So what is happening during interpolation is going back to the latent space. Each image corresponds to a point, like we said before, during inference, and then interpolation is just moving smoothly within your latent space to between different points. So that looks like this, moving from the lady here all the way up over to this man with a hat. One thing to note about StyleGAN is that with StyleGAN2, there are actually two different types of latent spaces. There is one called Z and one called W, which aren't really greatly named names. But Z space is this general latent space that exists in all different kinds of GANs. It's just kind of like what you get out of the box once you've trained a StyleGAN network. It's the latent space where every single point will correspond to an image. And it's, just sort of what you get without doing more stuff on top of it. W space was created specifically for StyleGAN2. It is a network that is meant to sort of disentangle what we call disentangling features. And what that means is in Z space, when you have a network that is trained, you might get things that don't really correspond to human readable features. So we might see things that don't make sense in terms of us thinking about things that are important to an image as humans. And W space is supposed to like sort of pull things out and make features correspond more to the features that we as humans would think of as features that we care about. So yeah, delving more into that and with an example, here's a picture of, I'm going to compare Z space and W space. So Z space again is just that latent space that is in all GANs that is just trained and has complete coverage. So here, this is interpolating between this woman on the left to this man all the way on the right. And during this linear interpolation, can someone tell me something that looks out of place along this interpolation? Feel free to just unmute and chat it out. Yeah, the glasses don't make any sense because you're going from someone without glasses to another person without glasses. But the model, for some reason, has just learned that glasses appear somewhere in the middle of this line. So what W space tries to do is it tries to sort of disentangle those features that don't really make sense to humans. And so here's the same interpolation between these two images, but in W space. Yeah, and the glasses. So here's a comparison of interpolation in Z and W space. They're similar, but slightly different.
Yeah, this case sense with faces, and it'll make less sense with other data sets. If you actually scrub through these two videos together, I think you'll see that but it's a little hard just looking at them.
Oh, Derek, I think you cut out for a little bit. Could you repeat that?
Working, but yeah, it's basically you scrub through it. I think you'll see there's very subtle differences, and I think in this example is sort of there's less orange in the W space. Yeah, you can see it exactly in this frame. Because you're going from pink to pink, there shouldn't really be introductions of orange, but there are in the Z space, and there's less in the W space.
Yeah, that makes sense. So like in this case, the orange are the glasses from the previous example that doesn't, like there's no reason for the orange to pop up. Yeah, so these are examples of linear interpolation. Linear interpolation you can do in both Z and W space. W space will be more disentangled in terms of the features. With linear interpolation, we'll go to the notebook in a second, but how you do it is you specify these points that you want. So you can specify, I don't know, seeds like 1, 5, 7, and 2. And then if you want a complete looping video, you just put 1 back at the end again, and then it'll loop back. The thing you have control over when you're creating a linear interpolation video is what these points actually are. So often what you'll do is you'll generate a bunch of fakes and then pick ones that you like, that you think would be cool to interpolate between. And then you specify those 4 or 10 or however many you want. One thing to note is in the video, which you'll be able to observe shortly, is that the speed can feel uneven between these legs because there are different lengths in the space. And what the interpolation script does is it generates the same number of frames per leg. So like this really short leg will have 30 frames, and this really long leg might also have 30 frames, which means that the really long leg will feel like it's moving really, really fast because it's doing a lot of change in the same amount of frames. So if we go over to the notebook for interpolation, there's a section on linear interpolation. To specify between Z space and W space, there's this argument walk type, and you can just put in line-Z or line-W if you want W space, the disentangle space. And then you can just go ahead and put in seeds that you want to interpolate between. So in this case, we're doing a looping video because we're coming back to 0 at the end, and it's going from, it'll have 4 different points that it's interpolating between. And these will be saved in this out directory z-walk. When I run this, that will be right here. And so it has all of these frames. And at the very, very bottom, there is this video, which is the concatenation of all these frames into a video. So if you wanted to view this, you would just go ahead here, download. And what that looked like was this. Oh no, wait, that is the noise loop, my bad. This one is the walk in Z space. So you can see it like gets to points and then sort of like pauses for a moment when it gets to the seed and then morphs back. And if you wanted to do W space, you just change that. You might want to change your out directory to W walk. And that will generate a video similar to this. There is another type of interpolation that is not linear interpolation called noise loop interpolation. Instead of being like this, I don't know, this polygon with corners, it's a smooth, I don't know, a smooth edge that's, yeah, pretty undefined in its shape. But the control you have in this when making a noise loop video is you only pick 1 point. You pick 1 seed as your start point, and then it'll just do sort of a random walk in the space and then come back to where it begins. So the reason why you might want to do a noise loop video as like an artist compared to a linear interpolation video is that with linear interpolation, you get these hard corners where it'll like pause at a second and then move. In a noise loop, it'll be more smooth overall, the video. But you only get control of that 1 frame. So noise loop is like, it's good if you want to just, if you don't really care what specific points show up and you just want to explore the latent space. But if you have specific images that you're like, I definitely want this in my video, then you might want to do linear interpolation instead. yeah, when you're doing, let's go to the section on noise loop. So in noise loop, you have control over your seed, and you do have control over another thing called diameter. That's not in here, but it is an argument. And what diameter will control is basically how big this loop is. If you want a really tight loop, you can make the diameter smaller. And then if you want, a greater exploration of the space where you'll get more diversity in your video, you can set that diameter larger. And yeah, just running this, we'll put it in this, we'll put it in a directory called noise1, and that will look like this. So this is, only defined by one seed that you input. Any questions about interpolation so far?
The videos that are not videos, the frames that are generated from this corresponds to the video, right? So if you were to, okay, download.
Yeah, so you could actually go ahead and zip this directory and then download the frames if you wanted to like manipulate the frames individually.
I kept the video pretty high res, but yeah, if you want to go like full resolution video, then you want to download the images and play with those. Yeah.
Yeah, and then one thing in Colab is you can't download, or you'll need to zip this file. There is a section up here on how to zip a directory. So if you wanted to zip this directory called out, you just use this command to zip it. Another thing you can do is mixing seeds. So here we have these 2 seeds, and then also in this top row we have 4 seeds. And then because like this latent space is just this space with the vectors in it, you can actually add different seeds to produce like their average or their sum. So you can see like each block in here is the sum of like the row and the column that it's in. Yeah, so like, because it is just like vector math, you can just add and subtract these seeds to each other. So what that looks like is if you have these 2 seeds, this orange one and this magenta one, or this yellow one and this magenta one, when you add 2 vectors, their resultant vector is like just this vector, which is just, it'll correspond to like the adding of these 2 images. And if we go to the notebook, back to the notebook, it's called style mixing here. But yeah, you just specify the rows and your columns with the seed numbers, and then that will output a image that is in here. So it saves like all of the blocks, and then also at the very bottom it has this grid.png that will end up looking like this. Yeah.
This is another one that's probably more fun with faces than it is with abstract stuff. I find it tends to just pick up like colors and texture a little bit and not necessarily change form as much. Whereas this is pretty clearly like if you add a person or if you add a woman with glasses and a man with glasses, you get like something in the middle. It's just like, it's a little bit clearer what's going on.
Yeah, I think generally if you have abstract stuff, it might be like harder in general to see what is happening exactly, but you might get something really cool. So just, try things and play with it. The last thing I'm going to like touch on is projection. So projection is pretty cool if you want to take an image, like some random image from out in the world, doesn't need to be from your data set, and then it will find the closest approximation within your trained model. So what that will look like is, here's this image of Harrison Ford, I believe. And the process of projection is like, it will go ahead and sort of take these steps closer and closer to its closest approximation of this image. So here's a video of that. So it starts off with like that most average woman, and then in more and more steps, it will try and get closer and closer to Harrison Ford. And yeah, it will, it won't ever really get to the exact image, but it'll get as close as it can. And the projection section is down here. So you'll need to upload an image. So you might just like go here and then upload your image. And that will be this target image. So you'll need to take the path here and then input the path. Here, this network can be your network. This path that we've put in here just for this demo is the FFHQ network, just so we can see it on faces. Earlier today, I put in a flower and projected that into FFHQ, which ended up being kind of terrifying as well. So you can see it like, it'll never really get there because it wasn't trained on flowers. But I think projection is a pretty cool technique if you want to see how, I don't know, the interaction of your data set with other things out in the wild. Any questions?
One thing I'll note here is if you do want to do faces into faces, there's a script that will actually, you know how I mentioned that FFHQ, all of it's aligned around your eyes. So one of the good things to do is if you want to find a much better representation of the face in FFHQ is to actually run that exact same process on your target image. I didn't do it here, and you can see it's like kind of a little off, but you could actually, there's a script to do what's called line faces, which will actually like rotate or align the thing along the eyes and then crop on it. That will usually give you better results for the actual face projection. So if you're interested in using that, let me know and I can send you the script for that. But again, for abstract stuff, it's kind of just weird. You like put weird images in and get weird images out, which can be fun in its own right. But if you're trying to do more realistic stuff, there's probably better ways to approach it than me just throwing a random image of a face in here and getting something that actually doesn't look terrible. Like it kind of catches, like, it's interesting that it catches like the curve of his hairline. It kind of catches the lighting a little bit, right? But it's still like pretty clearly not the right face or whatever. So.
And yeah, in addition to projection, there are a couple things that I'll just touch on, but not do full demos of. There's near neighbors. Near neighbors is like if you have a particular seed that you're like, I really like this seed, but I want to like see what's around it, see like what it'll look like if it, I don't know, was slightly different. So you can pick a seed and it will sort of explore the space like right around that seed. So I have this neighbors folder. This is for seed 9, which looks like this. And if we open a bunch of the neighbors, they're all like very similar, but like slightly different. So this is just if you want like if you want more selection from a particular seed. And then the last thing is this flesh digressions thing. From this person named ADA. They have a video of their flesh digressions here. Derek, I'm not exactly sure what flesh digressions is.
Yeah, I mean, I think the name describes it, what's going on here. Essentially what this is doing is, so again, in the layers of StyleGAN, the very first layer when you're generating an image is what's called the constant layer. And it takes in a constant value or like a constant series of values. And those tend to be pretty small, like they tend to be all within a very consistent range. What flesh digressions does is it takes that range and it like does lots of weird stuff in there. And then when you apply that to like the higher layers of your model, you get the same structure in weird different places. I like it as it's a way to have a little bit of fun with your model without it being like, oh, this is what everyone does with StyleGAN, right? So this is a kind of a case of like, when you're on faces, it's really clear that like the faces show up in weird spots. But if you try on your own abstract stuff, it's sort of the same idea of like things show up in different places, but it's still like, they still are kind of connecting in weird ways. It's just a fun thing to play with, and kind of a way to have a little bit of new way to play with your models. But yeah, it's pretty, I think the setup for the code is fairly self-explanatory. It's kind of like one of those things you don't have a lot of control over again. It chooses a lot of random values and you're sort of stuck with what you get. I will say so PSI is the same as truncation. You'll see people refer to it either as, I guess it's psi, it's actually a mathematic value, or truncation. Radius small is actually how big the loop is of that constant layer. So if you make that smaller, the constant layer is slower. If you make it bigger, the constant layer moves faster. And then the radius length is actually the length of the interpolation. So similar to what we're doing with like a noise loop, it does a loop on the actual vector, the input vector, that 512 dimensional vector. So the smaller you make that, the slower the output layer moves, and if you make it bigger, the faster that output layer moves. It does some weird stuff, and like this is, I believe it defaults to like a 13-second video. You can play with that value, but not too much. It's a little challenging to sort of like, this is definitely one of those that feels cool, but it's like hard to control. So if you're like, oh, I want to do this with it, it's like, maybe you can, maybe you can't. It's a fun one to play with, and I definitely recommend it, but it can be a little hard to figure out how to like control it.
And yeah, after running the flush digression script, it'll output in this video called circular25, or circular followed by the date. And I have it right here. Yep. Any questions?
Yes, I have a question about the projector.
Mhm.
How, like, what do you actually get back? Does it give you the closest seed, or does it give you coordinates?
I think you can. I think you can actually get out the vector, the .npy file, which is like that 512 dimensional vector. Yeah, I don't think it will not correspond to a particular seed, or you won't get like an integer value of a seed that you can get back. Yeah. Derek, do you have anything to add to that?
Yeah, so another thing I would recommend is, I believe at the very top of this file, or like toward the top of this file, there is a thing that shows, yeah, click there. Let's see if that's, and scroll up a little bit, I believe. Yeah, so there's this command called, basically what I always recommend is run --help from any script, and you'll see sort of like a dump of things you can do. And I don't know if this one actually shows all of the variables that can get passed in. Try this again. So try add in at the top there, try generate.py and, or sorry, do projection.py. And then run that. Nope, what is it called? Is it called projector?
Yeah, I think it's, yeah, projector.py.
I think they changed the name of it, of course, between these two different versions. Interesting. So this one doesn't save the vector out. I think I've got some code to do that. So if that's something that people want, I can add that to this repo, where basically we could just like add it. We could just do something like save vector, and we could output the vector. One thing I know about vectors is it's very easy to go from a seed to a vector. It is near impossible to go from a vector to a seed, because of just like the random values. You would have to do like this crazy search to actually find the right seed. So one thing that is probably broken in this version, but is fixed in another version, and I will slowly work on that, is you could also take inputs. Instead of taking an input of a seed value in a lot of these, you could take inputs from a actual vector file. They get saved out as, I believe, NPZ or NPY files. So you can actually just feed that path into this. It probably doesn't work in this version, but that's something I'll probably fix the next week or so. I just had to like sort of like decide what I was going to fix this week in my short time, but I'll add that as well. So yeah, because one thing you can start to do is you can start to play with like getting different vectors out and then begin to say like, okay, I like projection is like a great example of like you could project in two different images and then you can interpolate between those two, right? So that's a really good example of where you might want to use projection to get actual vectors out in order to do that manipulation. So I'll probably add that in the next week or so. But if I don't get to it, remind me and I can just make sure it works.
Okay. Yeah, and that's pretty much everything for sort of like the very basic like tool set of things you can do with inference and generating new images and video.
Leah, would you mind just sharing your screen and doing showing what the homework assignments are, or just like basically class is kind of over, and like if you want to stick around, I can show you some cool audio reactive and other stuff. But just knowing that like some people want to jump out, like maybe we can just show the final slides and make sure that everyone has what they need.
Yeah, for sure. So yeah, going ahead. Yeah, if you haven't started training, you can start training. You can also continue training. You know, help your model have enough time to reach its full potential. And yeah, I think, yeah, we have another co-working session this week?
Yeah, why not?
Okay,
Sure.
yeah. So yeah, if you run into any issues this week, attend a co-working session. We can help you work through that, or what you want to prepare for a show and tell, if you want to do a show and tell. Yeah, here's a slide full of like, I don't know, general administrative things that you can do. Sign up for our one-on-ones. You can pick any time. And it might generally be good to meet before the show and tell to sort of like prepare your project or any questions you have. Here are links to our Calendlies. The show and tell will be in about 2 weeks out from now, 2 weeks out or 2 to 3 weeks out from now. We want to pick a time that works for everybody, given the fact that you guys are like spread out all over the world. So pick a time that works for about a 2-hour slot. The presentations will be about like 7 to 10 minutes long. You can do like slides, or you can record a video if you don't want to present live, or the time is like hard for you to be presenting live at that time. You can just send a video. And then again, yeah, this is the last day of class, and please fill out a survey so we can improve and make it better for next year. Yeah, thank you guys all for being our awesome students in this class, and we're excited for the show and tell.
So one other note is, I believe in the first week of class, we linked to some other classes that might be of interest to folks. There's a collab class that talks a lot about collabs. If you're interested in digging in more into collab, you should definitely check out that. We just covered the very basics of inference in like the past hour. There is, from our previous StyleGAN in-depth course, there's like 2 extra weeks of like additional things that we cover. And most of that will probably be, you could do all of that from your current trainings. There might be some issues in terms of loading files in and that sort of thing. But we cover stuff like GAN space, feature vectors, other things. So I definitely recommend checking the last 2 weeks of that class, as you'll learn more. And you'll probably find lots of other cool uses of these sort of models. So check those videos out. And if there are any questions, or like if you get inspired to like maybe make something for show and tell and want to figure out how to convert your model to work with that, like let Leah or I know, and we can sort of send you some information about those things.
Mm-hmm.
So basically, like I'm gonna I'll probably stick around for another 20 minutes and show some advanced like we'll do audio reactive stuff. I'll just show a quick notebook that I have built up and walk people through it. So if you want to stick around, you can. Does anyone have any additional questions before we move on to that? Just sort of like wrap up class. Cool. If not, and you want to take off for the night, go for it. And I'll just sort of show a cool little audio reactive notebook I have. All right, let me share my screen and make sure my computer sound is on. And let me just make sure everyone can hear this. So if I play this, just give me a thumbs up if you can hear this.
I always let the day slip
Okay, cool.
away. I should have been making.
Is that like really loud or like? Okay, I don't know. Sorry, it's like very, very loud on my end, and I just never know what's going on. So just turn. If you like can't hear me, but you can hear the audio, just turn yourself down a little bit or whatever. I'll warn people before I play it. How about that? So that you can like turn it down. Sorry. No idea why that's so loud. Okay, anyway, so let me walk you through a notebook on how to do audio reactive stuff. This is very quickly made to work with the newest version of the repo, which means there's probably some issues here and there. So if you dig through it, just let me know that like you're trying, and if you run into issues, I will definitely try to fix things or like work with you on it. So this notebook also takes a little bit of a different direction than other notebooks where it's like we're running code directly from like a script that already exists inside the repo. And instead what we've sort of done here is we've dumped all the code directly into the cells, which means it can be really, really hard to read. But if you're interested in reading it, it's actually like maybe a better way to learn what's going on. So I'll just sort of quickly walk us through this, and then I will sort of show you like some examples. This notebook can get pretty long. So I'll just sort of like, I'll walk us through one example, and then I'll like sort of show you what the other ones can do if you're interested. So first thing we need to do pretty much in every notebook that you run with StyleGAN, the first thing you want to do is like make sure it's running TensorFlow 1, and then we're going to clone in again this the StyleGAN2 repo. Anytime you run the StyleGAN2 repo, you also need to install this thing called OpenSimplex that allows us to do the noise loops, but it's also like it'll throw errors if you don't install that. So just be aware of that. I believe I already have this installed, so I'm just not going to run the cell. Next thing is I always recommend just checking to see what kind of machine you have. So I believe I have a V100, which means we should be ready to go and like run through stuff really quickly. Next thing I'm going to do is I'm going to download one of my pickle files. This happens to be one that I like share with pretty much anyone. It's just like this abstract art thing I trained for a class a couple months ago. You're welcome to use this. You're welcome to like switch in your others. I know Stephen was asking like, how do I figure out how to do this? If you're interested in like figuring out what your ID is for your file, the way to do that is to go to whatever your like file folders are, and then find the pickle you want. Like let's say it's this one. Right click on it and then go get link. And for most people, this will be set to restricted. So you want to make sure this is set to anyone with the link, and then you'll copy the link. And then you'll come back to your notebook and you will paste that entire path in. And what you'll do is you actually want to delete the rest of the URL. Like basically this weird gobbledygook, like this is your ID. So you want everything but that. Or sorry, you want everything, you want that except and without anything else, whatever the terminology is for that. So you just delete this stuff and then you've got just this ID. And then -O, or -O says, where should I put this and what should I name it? So if you don't include anything here, it will take that original name, which I believe is something like, it's like network snapshot 0032, and I'll just use that. If you want to change the name of it, you can use -O and the location of it. So /content is always this folder, your basic like front folder. And then if you want to name it like mypickle.pickle, you could. I won't do this because I already have a pickle downloaded, but this is how you can get your pickle in from here. The other way is to always, if you mount Google Drive, you'll notice I haven't mounted Google Drive here, but you can also mount Google Drive and either drag it in or use that path. Both those work. I just tend to find that for this demo, it's a little bit easier just use G down because I'm not really looking at any of the training code or anything else. So in this case, it's a little bit easier to do this. Okay, so we've sort of like just got it started here. Next thing we need to do is we're going to upload an audio file. There's two ways to do this. One is just to drag. You can just literally like take the song and just like drag it into here, and that'll work. The other way is to run this like little code snippet, which gives you a little bit of like a nice little GUI where you can then go in and choose your file. So you go ahead and select this and hit upload, and it would upload your file. So that's how you get your audio file in. And basically what we want to do with this audio file is we're just going to take the volume of that audio file and use that to interpolate between two different seed values. Again, this is kind of, I definitely should clean this up to make it a little bit more user-friendly. It's kind of just like all tossed in here. But basically, the first thing you want to do is you want to set the path of your audio file. I believe 3 does work well, but I tend to just use waves just to make sure it's a little bit cleaner. So you'll just copy this path and you'll paste that in here. Next thing is, what do you want the frames per second to be? So this is for the output video. You could make it 60 frames per second and it would be really, really smooth. It'll also take a little bit longer to generate. You can make it 24, which is like a general, like, frames per second for video, that sort of thing. This does not have anything really to do with the length of your WAV file, right? So if your WAV file is 30 seconds long, it's going to generate, like, I think that ends up being like 720 or something in terms of the number of frames it needs to generate. But you just want to set 8 frames per second for your video, just so you know how, just so you can set that. I'm going to run this cell just to make sure. Also, one thing that I always tend to forget is a lot of times I have a cell that just sets variables and I forget to run it, and then I get error messages later because it's like, I don't know what you're asking me for. So make sure you run this cell. Next, here is a bunch of code. I'm going to run this and we can look and see what it does. This is just to get all of the various volume points within that audio file. So when I run this, it's going to go basically through that audio file and just try to figure out, like, the various values at every point. So the 24 frames per second determines how many points it's looking at in your audio file. But this is basically, if you've done anything with audio, this is the waveform of that audio file. So you'll see here, this is when she's singing and then it like falls off, and then it's singing and then it falls off. And you can sort of see like where the words are and where they aren't as it spikes. So what we want to do is, for this particular video, or for this particular interpolation, we're going to say when the volume is at 0, I want a particular seed value. And when the volume is at 1, I want a different seed value. So basically all it's going to do is interpolate between 2 different values using the same audio, or using 2 seed values, but using the audio to control where along that interpolation line you are. So next we're going to set up some code. This is, you will see this code pretty much all over the place in any of my files. This is how you actually, this is the code to actually generate images. You have to load in a pickle, you have to define a bunch of values, and then you actually need to feed in the variables and other things. You will see this code pretty much everywhere. There's also, how do I generate a Z from a seed? So if you're interested in this is actually how it reads in a seed value to generate a 512 dimensional vector. This is how we convert Z to W space, like that sort of thing. If you're interested in digging into this or have questions about it, I understand about 75% of it, and about 25% of it I don't, so I'm happy to talk through where I can. We're gonna run the cell just to make sure this is loaded into our notebook. And then lastly, this is sort of the code that actually puts it all together. So here we say what pickle am I using? So I want to provide the path to that pickle file. And then what seed values am I using? So again, this doesn't use the 512 dimensional vector, just uses a seed value. And then lastly, what truncation am I using? Pretty much anytime you want to generate a video or images, you need these 3 values. You need to know what pickle is it from, what's the truncation value, and what seed value am I looking for. So basically, when you walk through this notebook, you can change these values all you want. Pretty much anything below here, you probably won't want to change or need to change. It's fine if you do, but in general, you don't need to. So all this is doing then is it is taking in. So at this point, it's basically, it knows how many frames it needs to produce, right? Because it's like frames per second times how long the video is. So it's going to go through there and it's going to essentially convert the volume length, or the volume at that point, and then it's going to figure out where along this interpolation line it needs to be, and it's going to generate a vector in that space. So I've already run this. You'll see this needed to produce 700 images, so it would have taken a long time to run this. So I went ahead and ran it. This will generate a folder. The trick here is, because I haven't made this too clean, it generates a randomly numbered folder. That randomly numbered folder will be different every time. You will need to take this path and put that in here to generate the video. So make sure that this frame number matches this frame number. This will then generate the video. And then what you need to do is, so this will generate the video using the static, but it'll be silent. And then in this cell, you need to combine the video and the audio to produce a brand new video with sound. This is actually what most of the time what goes on behind the scenes, and you're just kind of seeing it all here and how gnarly it is. But this is sort of what goes on behind the scenes. So I went ahead and made this, and I've downloaded it. So I'm going to play it. So again, it's going to be loud. So if you want to turn your volume down, you've got 5 seconds to do that before I hit play. Okay, cool. Wait, where did that download to? Oh, here we go. Okay, so yeah, so I'm gonna play this and you'll, I don't know, depending on Okay, so you'll see that like as it spikes, it's like kind of hard to keep track of everything. But when the volume changes really slowly, right, as at that very last part, as she's like sort of like just letting her voice hang, like you see the interpolation happening much easier there. So this is a good example, but it's not a perfect one, right? Because it really just feels like you're almost only seeing two different versions of the same image, and it's just like you're sort of seeing stuff in between it, but it feels like they're more spiky. So pitch isn't always great unless you have like, let's say you have like a string section or something where it's like where it is going sort of high and low but much slower. You'll get a little bit more of a fluid video. So that's like the demo that I'm going to show you there. There are a bunch of other things in this notebook that if you want to look at something like controlling pitch, there's a way to actually get pitch read out of that same audio file. So basically this reads in, you have to install like a new repo or a new tool. This is the waveform for pitch, which I'm not sure how accurate it is. I'm not sure what Crepe is trained on. Crepe is actually a machine learning model. I think it's trained on piano or maybe voice. And basically it's trying to determine pitch from that. I would say this kind of makes sense. There's like some notes spiking. There's some other notes that are moving, and then I don't know, maybe this makes sense, maybe it doesn't. But anyway, it's like the right feeling, right? So again, here what we want to do is interpolate from 0 to 1, but this is going to give us less spikes and more of like slowly changing values. The hope is at least. So you would go ahead and run this. It's almost the exact same thing. There's just a little bit less code to run, and that would generate hopefully a animation that tracks more to pitch. Because this is a machine learning model, it's not always perfect. And I would say this works better for like solo instruments or individual like solo voices. If you try and run this on like a whole band ensemble, it's going to like be all over the place and not really know how it's working. So a lot of these videos tend to work better if you have a single instrument or a single voice, just because it's easier to track those sort of sounds, right? If you imagine like a band playing, like the volume is always going to be at a certain height, like is going to be very less, there's going to be a lot less sort of change there. So just think about that depending on your input source. The other example here is one that uses volume to control truncation. So again, we've got sort of like interpolation we could change, we've got truncation we could change. Maybe we could change, I think those are probably like a couple of the big things that we could actually change. If you watch the videos in a later session, I show how to use feature vectors, which is kind of covered here at the very end. Because I don't actually have a feature vector file set up, it's kind of hard to explain, but feature vectors might control individual things like opening your mouth or closing your mouth, or I don't know, turning your head or that sort of thing. Those do exist. You can get them out. It's kind of a gnarly process, but you could do that. So this one, this code sample here does truncation. So if you want to play with truncation as a part of your audio signal, you can do that here. And then this last one controls feature vectors. So you could look at controlling a feature vector using a sound, which I'm not sure even, I guess somewhere I installed this. So I think I covered a lot of this in those two other StyleGAN videos. So you might want to watch those, and they might explain a little bit more what's going on here and where to get these files. The last thing I'll mention about audio is that there is an example all the way at the top of the file here by Robert Luxemburg. And what this does, this is like super advanced level, is this actually takes different audio signals to control different values. So there are like, you can probably find on the internet some isolated channels or stems, what they call stems, of different songs, right? So you can find like the bass track, the drums, the keyboard, and then the vocals. And what he's doing is he's loading in each of those audio samples as their own thing and having each of them control different layers or different values. So one is controlling opening a person's mouth, another is controlling sort of truncation, another might be controlling sort of interpolation as you move. And then he like combines them all into one video. And I think the example is probably in our week 1 inspiration materials. I'll try to find the link to it again. But that's sort of what this code does. If you want to dig into it a little bit more, I'm happy to walk people through it. It's essentially like, it's not really that different than what is in this notebook. It's just like, it's doing it multiple times, and it's like keeping track of the audio tracks in different places. So that's where it gets a little challenging. And then you have to do the mapping in different places. But it's a cool way to work. It just definitely takes like, wrapping your brain around like keeping track of all those things can be a little hard. So you can do some really, really cool stuff using just audio reactive, as long as you're mapping things to the right values. And that's sort of one of the keys, I think, that's really important to think about in terms of just like how StyleGAN works, right? StyleGAN has these ideas of vectors and truncation. Like those are the two main components that make up any image, and they're just numbers. So anything you can do to manipulate numbers, you can do to like manipulate a StyleGAN model. And then it's just about sort of like figuring out the right mapping sequence, or mapping the right things to things that make sense. And that's where people tend to get into feature vectors, because feature vectors are a way to like sort of visualize individual components of a particular model. One thing to talk about when we talk about feature vectors is there is a tool called GANSpace that a lot of people use. And GANSpace, let's see here. So there are a lot of people doing stuff with StyleGAN2. Not all of them are using the official version of StyleGAN, which is, shit, it's not in here. Oh, that's because it's in StyleGAN2 training. So TensorFlow is the official StyleGAN version. There is a fork of it written in PyTorch, which is just a different version. Lots of people tend to like PyTorch more than they like TensorFlow. So a lot of times there are tools written in PyTorch that you need to use. The challenge there is that you can't use a pickle file in PyTorch. You use a .pt file. So you will need to convert your pickle file to a .pt file in order to use it. This notebook will do that for you. So when you hit GANSpace or when you hit some other tools that are in the PyTorch world, they'll look for a PT version, and this will work. So, and actually this should be fairly straightforward, because really the only thing you're changing is like your pickle file. Everything else should work as is. So walk through this and read through the steps. I'm not sure if I have a video on this yet. I probably do. Maybe if I don't, I'll find it and record one. But essentially this will convert your file to a .pt model. When you've got your .pt model, you want to make sure you either download it or move it to Drive to make sure it's saved. So just like a pickle file, you don't want to lose those, because it's like you have to recreate it, but you need it every time to do this. So just be aware of that. It is one of the annoying parts of sort of the StyleGAN2 ecosystem. The PyTorch model is this one. So this is the this one. So this tends to be the one that lots of people use. And in fact, one thing I haven't gotten to yet is that there is this closed form factorization, which is apparently an even easier way to get out feature vectors than GANSpace. GANSpace takes like an hour or two to process, and then you have to like go through and actually like see what all the variables are, which can be pretty challenging. It's why there's like almost a whole class devoted to it from our previous classes. But this is a version I want to look at over the next couple weeks to make sure that like this might be an easier way to actually produce that. But again, you need to produce it in a .pt file so that you can actually generate those vectors. So yeah, feature vectors are like a whole category in of themselves. And I feel like there's been, since we last taught the StyleGAN2 class, there's been like 3 or 4 new models to try to generate feature vectors. I don't know who saw this, if you saw that Photoshop just came out with sort of what they call neural filters, which is a way to basically like use feature vectors to change people's faces in Photoshop. So the reason there's a lot of people generating feature vectors, especially around faces, is for that exactly. The idea of face filters like through TikTok or like Snapchat or other things, like very, very popular to like age someone or make someone's mouth do something funky or funny. It's a very, very popular field right now. And my hope is that Photoshop has kind of killed it off a little bit by making it sort of like clearly like someone solved it. So we're good to move on to other things. But feature vectors are like a very, very popular topic. And it's also something that like makes sense even for our own artwork, right? Like, so even if you aren't doing faces, like it's very clear, like, make someone smile or give someone a beard or like, make them look older or younger. Those things make a lot of sense. But even again, like what we saw with the flowers is like, you know, what if I just want to change the color of the flowers, but I want to keep the structure intact? Or what if I want to grow leaves to make the leaves bigger or smaller? Like those are all features that we would love to have available to us in the model. And right now they're sort of hard to get access to. So that's something that I'm definitely like over the next, now that I have a month or two off from classes, I'll be like doing more deep dives into those. So you can keep an eye out for video to cover those materials. But yeah, essentially, like, I think it'd be fun if people want to dig into this. I'm happy to like sort of set up some time to walk through some feature vector stuff. But yeah, in general, like you will often see people say like, we need a .pt file, or it's written in PyTorch, and it's written in PyTorch. Basically, won't import a pickle, and you convert it to a .pt file. Okay, cool. That covers most of the advanced stuff I wanted to cover. Are there any questions? All right. Cool. Well, then what I would say is like, one, please sign up for, or like, please tell us what times work for show and tell. Because hopefully Leah and I in the next couple of days can set up a time for that. Once we have that set up, we'll let everyone know in the Slack channel what it is. And I'll set up a streaming sort of countdown so people can link to the video or whatever. And then please like, so we'll do co-working for the next week. And then we'll do one-on-ones like either starting now until the end, until show and tell. Actually, one-on-ones you can schedule whenever you want to. Like if you like don't want to do show and tell, but you want to like save time to talk to me, like, you know, and talk to us in December, you're more than welcome to do that. But I also would recommend that you set up a time, because lots of people say they'll set up times and they forget, or it just like falls off their radar. So setting up a time at least like puts something in our calendars and sort of like makes you commit to showing up or like talking through things. So yeah, with that, I hope everyone had a really great class. Please also fill out the survey. And hopefully we'll talk more over the next couple weeks before show and tell.
Thank you.
All right. Thanks so much, guys. Bye,
Thank you
everybody.
guys. Bye.